Hi everyone, this is Dr. Fox, and let's talk about the muscles of facial expression. In this video, we'll discuss the various groups of facial muscles, or mimic muscles, how they're distributed about the face, their functions, and their innervations. In the lead-off video of this series, we discussed the various orifices of the face. For every set of orifices, or every orifice, there are a unique set of muscles associated with them, with the exception of the epicranial muscles. Now, when we think about the muscles of the head, or at least the superficial muscles of the head, we could divide them into two groups. The epicranial, epi means upon the cranium, and the craniofacial. Cranio references the cranium and facial references the face. The craniofacial muscles are going to be grouped into muscle groups that pertain to orifices. So, for instance, the circumorbital and palpebral muscles will pertain to the palpebral fissures. The nasal muscles will pertain to the nares, and the buccolabial muscles, that's cheek and lips, will pertain to the oral fissure. So let's take a look at these groups, see where they are, see how to identify the muscles, discuss their actions and their innervations. So let's start with the epicranial muscles. There is one major epicranial muscle that we'll be focusing on in this video, and that is the occipitofrontalis. Now, there are very many different types of conventions for naming muscles. This particular one describes the two bellies which comprise the muscle fibers of this muscle. So, occipito references the occiput, which is the occipital bone, and frontalis references the frontal bone, which is in the front of the cranium. Now, the occipitofrontalis has two unique bellies. There is a frontal belly. You can see that over here. That would be this. And there is an occipital belly. The occipital belly tends to atrophy with age and can be a little less distinct in the population of donors with whom we're dealing. And between the two is something known as an epicranial aponeurosis. So epicranium upon the cranium, aponeurosis is a sheet of connective tissues that's like a tendon. And so this epicranial aponeurosis attaches these two bellies together. So when either of these bellies contracts, it's going to elevate the skin of the brow. And so any of this action will pull the scalp posteriorly. Now, both of these bellies are going to be innervated by branches of the facial nerve, cranial nerve 7, and it would probably behoove you to sit down and look at the major branches of the facial nerve, or at least have them next to you as we go through this video. So for the frontal belly, there are temporal branches of the facial nerve which innervate it. And for the occipital belly, there's a particular branch of the posterior auricular nerve of the facial nerve. So that posterior auricular nerve is heading that way after the motor trunk leaves the stylomastoid foramen. And there are branches to auricular muscles, and then there is a branch to that occipital belly itself called the occipital branch of the posterior auricular nerve. So as you can see here in our demonstrator, when we activate the occipitofrontalis muscle, the forehead is is going to elevate. Along with it, even the eyebrows can elevate, so as to indicate surprise or skepticism or hey. So now let's look at some of the groups of the craniofacial muscles. Let's start with the circumorbital and palpebral muscles. So keeping in mind that the palpebrae are the eyelids, both superior and inferior. And the orbit is the space within the cranium where the eye and extraocular muscles and associated structures live. So the first muscle that we'll discuss is the orbicularis oculi. So orbicularis is part of our muscle naming convention. Anytime you see orbicularis, that means that the fibers of the muscle are arranged in a circle. So we have fibers here. We can see them arranged going around the orifice. So oculi or oculi references the eye. So this is a circular muscle about the eye. There are three parts to this muscle, two of which we'll discuss in this session. The third we'll discuss in the context of the orbit. So they include the orbital part, and let me just outline the orbital part for us. The orbital part is this expansive portion that wraps all around the orbit, with the exception of this. So that orbital part is what we use to voluntarily close the palpebral fissure. So when you decide to shut your eye or to wink, so you're closing that eye almost like a sphincter, you're using that orbital part. We can contrast that with the palpebral part, which is just upon the palpebrae. The palpebral part is only active in blinking. So this is an involuntary part of the muscle. So the orbital part is when you voluntarily shut your eye. The palpebral part is when you involuntarily shut your eye, such as in the case of blinking. There's also a lacrimal part, pardon me, that we cannot see here. It is deep, and it is in association with the lacrimal apparatus. So this is the space into which tears drain, and we'll discuss that when we discuss the orbit. So the orbicularis oculi muscle is innervated by both temporal and zygomatic branches of the facial nerve. One way to kind of remember this is I use that lateral canthus or angle of the eye to differentiate between branches of the facial nerve, in that temporal branches generally are going to be superior to that, and zygomatic branches tend to be inferior to that. So as the palpebral fissure is a landmark for denoting where temporal versus zygomatic branches are, it's not too much of a stretch to remember that both temporal and zygomatic branches of the facial nerve innervate orbicularis oculi. So here on our demonstrator, we can see activation of orbicularis oculi. That's not a significant shut, but it is unilateral, suggesting that is voluntary. So more than likely, some portion of that orbital part was recruited to accomplish that. Our next muscle is going to be deep to the orbital part of orbicularis oculi, and this is a muscle known as corrugator supercilii. So corrugator is something that produces ridges, and supercilii references the skin here above the brow. And so when this muscle is activated, you have kind of an oblique furrowing of the brow. In this particular demonstration, both corrugator supercilii muscles are activated, and what that does, it's kind of in conjunction with the orbicularis oculi. You tend to squint a little. So this is thought of as an action that people use in very bright light, so as to limit their the light exposure to their eyes. It's also something that we might use, to express skepticism or annoyance with an individual. Corrugator supercilii are innervated by temporal branches of the facial nerve. Now let's skip over the muscles of the nose for a moment and jump down to the buccolabial muscles, of which there are many. So let's start with this lovely. This is a muscle that is fairly easy to locate in the lab. This is levator labii superioris. So this muscle is named for both its action and where it's located, or just purely its action, depending on how you want to look at it. So levator labii superioris is going to be an elevator of the upper lip. So when this muscle fires, as we can see here, the upper lip is going to elevate. As we move laterally, we get to the zygomatic muscles. These can be rather inconstant, so we don't see both zygomaticus minor and major muscles in every donor. So there's a little bit of variability. But the first one that we come across is zygomaticus minor. So that would be the smaller zygomaticus muscle. Zygoma is the cheek. It references the zygomatic bone, which these muscles are attaching to connective tissues in the proximity of. And so when zygomaticus minor fires, we can see it on this side. This is just unilateral. We have the exposure of a more lateral smile. Usually, we can see just to beyond the canine tooth. So, wanted to just expose your canines with a kind of a weird smile, like zygomaticus minor would be recruited. Zygomaticus major is the larger of the two, and so these are muscles that are interacting with the modiolus here, because they're pulling the corner of the mouth as well. And with zygomaticus major, you have an even wider smile. So this is unilateral, so it still looks like she's being very skeptical, but if you made this bilaterally, this would be a greater smile. And she's also not engaging her eyes in the smile, so that's why it might not look very genuine to us. All three of these upper lip muscles are innervated by both zygomatic branches and buccal branches of the facial nerve. So the zygomatic branches are heading that way. Buccal branches are heading towards the mouth, as we'll see. Behind these muscles, so if you were to take a look at these as a group, and you can even include this one nasal muscle here, behind those muscles is a fascial space known as the infraorbital or canine fascial space. Anatomists will call it the infraorbital space. Clinicians like to call it the canine space because, well, it's largely going to be posterior to the canines. a lot of maxillary odontogenic infections. So those infections that are arising from teeth of the upper jaw are going to first drain into that canine fascial space. And they can move elsewhere, as we'll see. That communicates with the buccal space as well. So let's continue on with the buccolabial muscles because we have so many of them. Next up is orbicularis oris. Ooh, remember that word, orbicularis? And what it means? It means the fibers of the muscle are arranged in a circle, so as to provide sort of like a sphincter effect. Orbicularis oris, oris references the oral cavity, is the muscle that really controls the patency of that oral fissure. When you relax it, you can open the oral fissure. When you tighten it, it closes the oral fissure. And if you really extremely tighten it, it will purse the lips. It'll bring them together in sort of the classically panned social media duck face that people make sometimes. Or, as if you're offering someone a kiss. Either way. I guess that's probably the basis of that face anyways. Let's see. Orbicularis oris is innervated by both buccal and a new branch of the facial nerve to us in this video, the marginal mandibular. So recall the buccal branches head out this way. The marginal mandibular branch is heading out along that inferior margin of the mandible. So that is exquisitely well named. The next muscle, I really like this one a lot. This is the buccinator muscle. So the buccinator muscle is the major muscle of the cheek. So this muscle goes superiorly to the maxilla, inferiorly to the mandible, posteriorly to the pterygomandibular raphe, which connects to the superior pharyngeal constrictor. And what this muscle does is that it draws your cheeks toward the teeth. So any materials that you're chewing get pushed from your oral vestibule into the occlusal surfaces between and of your teeth. So this is very helpful when you're, say, eating, so that you can bring those foodstuffs and materials in between the teeth so that they can do their jobs of cutting and grinding. So as you can see here, she is drawing those. This is a little exaggerated. She's probably creating a vacuum in her mouth to show this, because otherwise it would be a very imperceptible action. The buccinator muscle is innervated by buccal branches of 7, so that's nice and easy to remember. And there are a few additional things that we should discuss regarding it. Superior to it, or superficial to it, is going to be buccopharyngeal fascia, which invests it. And then above that buccopharyngeal fascia, all the way up to the SMAS, is our buccal fascial space. And within that buccal fascial space, we have both the buccal fat pad, that large chunk of adipose connective tissue that gives the face more of a rounded, or some people refer to it as a youthful appearance. And we also have the parotid or Stenson's duct moving through that space as well. So Stenson's duct moves through the space and it pierces through the buccinator muscle on its way to the oral vestibule, where the papilla for it is actually adjacent to the maxillary second molars. So that's where the parotid gland is going to secrete into the oral vestibule. We can also see a branch of a nerve here, and this will be a a topic for a later video. But this nerve is the buccal branch of the mandibular nerve, or of V3. That's the third branch of the trigeminal nerve, which is cranial nerve 5. This is a sensory nerve which is conducted through this space, and we'll discuss this in more granular detail in a subsequent video. So moving right along, we've got more we've got more buccolabial muscles. So imagine that we are deep to the zygomaticus muscles, and even deep in part to levator labii superioris muscle. Well, we have levator angulioris. So let's dissect that name, shall we? Pun intended. Levator means something that elevates. Anguli is the angle of the mouth. So levator angulioris is going to elevate the angle of the mouth. So it tugs the modiolus superolaterally. Levator angulioris is innervated by buccal branches of the facial nerve. So we can see here she has more of a devious smile this time because she's not really engaging many other muscles, but you can see it's a slight smile with levator angulioris. Next up, this is one of my favorites. Is the risorius muscle. The risorius muscle you can sometimes find as we are dissecting. It runs from the modiolus more laterally along the face, and it pulls the modiolus laterally. So if you can imagine, well, you don't even have to imagine because we've got it right here, a slight smirk, like, huh. That's the risorius muscle. Risorius, like levator angulioris, is innervated by buccal branches of the facial nerve. Okay, now we've talked about all the smiley and smirky muscles. Let's talk about the frowny muscles. These include the depressor angulioris. So depressor depresses the angle of the mouth. This pulls the modiolus inferolaterally. Depressor angulioris has a triangular morphology to it, and you can see it more laterally flanking the chin region. And this is your frowny face muscle. Depressor angulioris is innervated by both buccal and marginal mandibular branches of the facial nerve. We also have depressor labii inferioris. Depressor labii inferioris is found sort of tucking underneath depressor angulioris, and it's also underneath orbicularis oris, kind of running obliquely like this. Depressor labii inferioris, as its name suggests, depresses the lower or inferior lip. Depressor labii inferioris is innervated by the marginal mandibular branch of the facial nerve. And then finally, we have the mentalis. The mentalis is a muscle that is medial toward the chin. It is also innervated by the marginal mandibular branch, but when activated, it elevates some of the chin skin and it protrudes the lower lip. So the mentalis muscle is a pouty muscle. And we've escaped largely, so we'll put an asterisk by that because we've got part of one more muscle to discuss, the buccolabial muscles. Now let's look at the nasal muscles. And this next muscle is an excellent transition because it's also very weakly a buccolabial muscle. So this muscle has the distinct honor of having the longest muscle name of any muscle in a vertebrate. So it is the levator labii superioris aliqui nasi muscle. So let's break that one down. It's an elevator of the upper lip and also the wing of the nose. There are two slips to this muscle. Let's look at it down here. Here's one slip that goes to the upper lip. There's another slip that goes out to the ala of the nose. So when this muscle contracts, it's going to both elevate the upper lip on that one side and it's going to dilate the nostril. We can see that here. There's the dilated nostril and here's the elevated upper lip. I like to think of this as almost like a snarl, or if you can still relate, or if you've heard of Elvis and have ever seen a video of that face that he made, that classic Elvis face is compliments of levator labii superioris aliqui nasi. This is a muscle that is innervated by both zygomatic and buccal branches of the facial nerve. Finally, we've got the nasal muscle, or the nasalis. It is also innervated by the zygomatic and buccal branches of the facial nerve. There are two parts to it. There's the transverse part, which we can see here. It kind of goes over the bridge of the nose, kind of down like that. This muscle is sometimes referred to as its very own muscle, called the compressor naris muscle, because when it is activated, it compresses the nostril. You can see that here. And then there is an alar part, which is a little slip of it right there, that is sometimes referred to as the dilator naris, because it pulls the ala of the naris laterally to dilate it, or to let more air in. Wonderful, wonderful. We can see that here. So that concludes our high-level view of the facial muscles and brings us to our assessment question of the video, and that is, which muscle may both elevate the upper lip and dilate the naris? Well, it's going to be something that touches the upper lip and touches the nose, but if we're dilating the naris, we have to connect to the ala of the nose. So levator anguli oris doesn't really elevate the upper lip. It pulls the modiolus, so that's not a good one. Levator labii superioris will elevate the upper lip, check, but it doesn't really do anything to the ala. Levator labii superioris, that's half of it. Aliqui nasi, that's the other half of it. I'd say that's the great answer. The zygomaticus muscles, they're going to pull on the modiolus, but they're not going to do anything to the nose. So let's call levator labii superioris aliqui nasi the correct answer and move on to the next video. Thanks so much for your time, and I'll talk to you soon.